Okay, so we're gonna start with spring 2018 final with number 13. And then we'll just take questions from here. Okay. So here's number 13. We're given an equation and we want to solve for the variable m. So this is called a literal equation, which we studied in probably chapter 1, somewhere in one of those chapters. So this question is coming from spring 2018. Okay, so if I'm solving for m, capital M, well, let's locate it right here. So you want to isolate m. So how do we do that? Well, first we want to get rid of r squared from the bottom. So let's go ahead and multiply by r squared on both sides. So we have r squared times f is equal to g little m and big M. And then from here, again, I still want to isolate big M, so I'm going to go divide by g times little m. So that will give us this expression. So now the variable we're after, m, is equal to r squared times f over big G and little g. So that would be the answer for big M. Now keep in mind, guys, when you're typing your answers on WebAssign, if the letters are small, use small letters. If they're big, then use capital letters, because the system is super sensitive. Even if you put a space, it marks it wrong. If you put uppercase, lowercase, just make sure to keep same notation as how the system gives it to you.
Yeah, I have a question for the last was it quiz? Yeah, quiz.
Mm-hmm.
You know, there's questions that we have to write in.
Mm-hmm.
And sometimes, I don't know, like, you know, like you said, it's very sensitive. So do you go over those type of questions, like what we put students?
Yeah, I'm gonna have to recheck last quiz. I haven't done it yet.
Okay, thank you.
Yeah, I'm gonna do that sometime this weekend, but it will be done before sometime next week.
I have a question.
Go ahead.
So with our final, when we get the score, is it automatically put into our grade center? Because like you said, since it's case sensitive and things like that, you cannot go back and like check it, right?
Well, so for WebAssign, you can actually check. Well, I mean, you can actually see all the question at the same time.
Yeah, but let's say like it's case sensitive and you know, even if the answer is right, but we put it wrong, like if we put a space or anything, and later on after the quiz or something, if we tell you, like, are you able to go back and check like you did with Blackboard? You're not, right?
No, I'm not, because WebAssign, well, they're all multiple choice, and the written response, they will grade it for you. So the system will do it for you. And I would say don't be scared because of that, guys, because if you've been doing the homework, the questions for the final are similar to your homework questions. So if you know how to enter answers for your homework, you should know how to enter answers for the final. So you should not be afraid. How do you enter answers? Okay. Does that make sense, Richie?
Yep.
Okay, great. So homework is your best friend. You should know how to do them, and you should know how to enter them, since you have like 2-3 chances to correct your answer. But for the final, you only have one chance. So just be careful and just check your answer before you input something. All right. Any other questions, guys?
Wait, another question, sorry.
Sure.
In the homework, some of like I've encountered questions where they ask for exact values, like they will ask you to round it to the, you know, 3 spaces or 2 spaces. Are those type of questions going to be on the final? Because like on the homework, they will tell you if you have to round it that you need to use a calculator or not. Like for the last homework, they did tell us those type of questions going to be in the final? Because I know that we're not allowed to use our calculators and stuff.
Right, so I believe those are not on the final because there's no calculator question. Everything you should be able to do without a calculator.
Okay, thank you.
No problem. Okay, all right, any other questions, guys?
Yes, I have one.
Sure.
It's from the web assigned homework.
Okay.
I'll read it. It says
So let's do this one. So this one is coming from WebAssign. So we're going to let theta equals to the inner function, which is this piece right here. So you have theta is cosine inverse of 20 over 29. So that means if I apply cosine on both sides, I have cosine theta is equal to 20 over 29. Now from here, we don't know what theta is, but we can actually create a right triangle and figure out the missing length from there. So WebAssign does give you the right triangle, but you should know you have to create it regardless what the question is giving it to you or not. So theta could locate here or on the upper corner. So if it's here, then across from theta is your opposite side. This is adjacent, and it says hypotenuse. So cosine is by definition adjacent over hypotenuse, which means that we have adjacent 20 and hypotenuse 29. So now we can find the missing length. So how do you find the missing length of this triangle? You can
use sine. So sine theta equals x over 29.
Well, that's the thing. You don't want to put x in the answer. So we know the final answer is sine of theta because cosine inverse of 20 over 29 is theta. But we don't want to use any unknown in our answer because we know how to find this unknown side by Pythagorean's theorem, right? So we're missing one of the leg. So a squared plus b squared is equal to c squared. So let's call the missing length to be b. So a squared, that's 20 squared, plus question mark square is equal to 29 square. And that will allow you to find the question mark. So have you got this part, Richie?
Yeah, I understand and now this part I do.
Okay, so 20 square is about 400. We have question mark square, and 29 square, that's a huge number. 841, right? It's a perfect square. And then subtract away 400 from both sides. You have 441 equals question mark square, well, question mark square. And then to solve for question mark, we're going to take the square root on both sides. What's the square root of 441?
21.
21. Thanks. There you go. So that's our missing length. Now the final answer that we're looking for is sine theta. So what is sine theta by definition? Sine is opposite over hypotenuse. So our opposite is 21 and hypotenuse is 29. So that's the exact value you're looking for. Any questions for this problem?
Oh, so of cosine of that value, you get an angle and then you input.
Right. Right. So for the inner function, we are able to draw a right triangle, and then from there you figure out the missing length, and then going back to your original question, you rewrite your trig expression as a sine of theta or cosine theta, whatever it is. In this case, it's sine theta. So then from the picture, we read off what is sine theta. Do you want me to give you another question similar to this?
Okay, got it. Thank you.
Okay, no problem. So Do you guys want to see another question similar to this, or this is clear?
Well, we can see another one.
Okay, so right, it doesn't hurt to do another one. So take a look at this one. What if we want to find, let's say, cosine of cotangent inverse of 2, let's see, 2/3. Okay, so I'll give you a couple of seconds. Think about this, and then we'll start in just about 30 seconds. Okay, so let's think about this question. So again, we're going to let theta be the inner function. Okay, so let theta be equal to cotangent inverse of 2/3. So that means cotangent of theta is equal to 2/3. Okay, so now we can draw a right triangle by using the definition of cotangent. So here's our right triangle. And again, you can replace theta either on the upper corner or the bottom corner. So I'm gonna keep it on the bottom. No reason, it's just nice to keep theta on the bottom. So cotangent, what's the definition of cotangent? Well, it's the reciprocal of tangent, right? So if tangent is opposite over adjacent, cotangent will be adjacent over opposite. So from the picture, we know this is our opposite length, this is adjacent, and this is hypotenuse. So let's fill this in. So we have opposite, well, we have adjacent, which is 2, and opposite is 3. So now we're looking for the hypotenuse. So same idea, we're going to use Pythagorean's identity, or Pythagorean's theorem, to find the missing length. A squared plus B squared is equal to C squared. So for this triangle, our question mark is the hypotenuse, so that's C squared, and we have the 2 legs, so I can label them either A or B. So let's just call this is A squared and this is B squared. So then we have 3 squared, that's 9, and then 2 squared, that's 4, is equal to question mark square. So what is question mark equal to?
$13.
Well, it will be a square root, right?
Yeah.
Right, so question mark is square root of 13. Perfect. So now we're almost done with our problem. We're going back to the original question. We have cosine of theta, since we replaced cotangent inverse with theta. So we're evaluating cosine of this unknown theta. And by definition, cosine is adjacent over hypotenuse. So we have 2 over radical 13. That's your final answer. And if you want to rationalize it, you could rationalize, but it won't be necessary. But if you want to, it will be 2 radical 13 over 13. So that would be rationalized answer. Okay. So any questions on these type of problem?
So I have a question. So I understand how you approach your answer, but then when I was trying to do it by myself like a minute ago, so you have cotangent of theta, which is 2/3, right? And isn't tangent is sine over cosine, right? So cotangent is cosine over sine. And if the numerator value of cotangent is 2, why cannot cosine of theta be 2?
Well, so here's the thing. If you let's come back to this definition. So we know cotangent is, so tangent is sine over cosine, so this is cosine over sine. So if you are, so how do we say this? So think about it this way. These values, they don't really correspond to the trig values. They don't correspond to these numbers we have. They correspond to a length of a right triangle, okay? So when you use the definition for cotangent for a right triangle, you're not using this definition. You're using that when you have an identity, when you're rewriting an equation or an identity. That's the only time you relate the cotangent with sine or cosine. But when you're using a right triangle where theta is unknown, you have to make a right triangle, and the values you have, they're the length of the triangle. So that's where we have the definition, which is opposite, adjacent, hypotenuse. So sine and cosine, they're not really the definition of cotangent. They're just one way to rewrite cotangent. Does that make sense, Richie?
Yes, a little bit. Thank you.
Okay. So these are just the length of a triangle. They're not really the sine and cosine values, so you can just equate them. Okay. All right. Any other question? Okay, Faith, do you have a question?
Okay, Professor, I have a class right now, but I just wanted to know, are you gonna post the recording of this video on Blackboard of this?
Yeah, I'm gonna put it up later.
Oh, okay. It's gonna be there before nighttime, right?
Oh, it depends how long it takes to upload. But it'll be up sometime later today or tomorrow.
Okay, okay. Thank you. I just wanted to know that.
Yeah, no problem. All right. Do we have any other math question?
Oh, we can go and see like other problems from the spring 2018 final.
Okay, so let's do that. So while you guys are either looking for questions or something to review, we're just gonna focus on spring 2018 meanwhile. So let's take a look at that final. So here's the spring 2018 final. And we want to, let's see. So I did do some question yesterday. So why don't we go ahead and do some trigonometric stuff since we did that at the end of the course. Number 2, right? We want to find a coterminal angle. So that's something related to what we did almost at the end. So let's work on that question. So unless you guys want to pick a question, I can do that as well. But for now, let's do this one. Okay. So we want to find a coterminal angle with 17 pi over 6. So the idea with coterminal angle is to either add 2 pi or subtract 2 pi, depending on which direction you're headed and depending on what angle you're given. Now, we want a coterminal that is between 0 and 2 pi. So that means we need to actually, so what do you guys think? Do we add or subtract 2 pi?
Subtract.
Right, because this is 17 pi over 6, which is huge. So if you want to bring it smaller, you would have to subtract 2 pi. So we take 17 pi over 6, and we're going to subtract 2 pi. So that would give us what? We want to put them in common denominators. So multiply this with 6 over 6. So we have 17 pi over 6 minus 12 pi over 6. So what will that give us? 5 pi over 6. Now, is this within the boundary of 0 to 2 pi?
No.
So let's check, right? How do we know? Well, so now the question is, do you want to keep subtracting 2 pi, or do we have the angle that we want? So we're going to rewrite 5 pi over 6. Or if you want to convert it to degree and get the degree measure, you can also do that. But that would take you so much time. So let's not do that. So let's rewrite and see if it is within the boundary you're looking for. So 5 pi over 6. I'm going to rewrite 5 as a factor of 3 and 2 because I can simplify that with the denominator. So 5 pi, that's 3 pi over 6 plus 2 pi over 6. So that's 5 pi. And then 3 over 6, that simplifies to pi over 2. And then 2 pi over 6 simplifies to pi over 3. And now these are the measures that you should be familiar with. Pi over 2, that's 90. And pi over 3, that's about 60. So 90 plus 60, all that's 150. So yes, this is within the boundary we're looking for. So there you have your coterminal that is between 0 to 2 pi. Any questions?
Can you do number 8?
Number 8. Okay. All right, so now let's pull out number 8 from the final. Okay, so number 8 is okay, so here's number 8. So we want to figure out what is cosine theta is, and given sine theta is 2 over 9. So we're also given which quadrant we're going to draw the angle, okay? So this boundary tells us which quadrant theta belongs to, and we're given sine of theta, we're looking for cosine. So we're gonna have to create a right triangle. So again, every time you're creating a right triangle, you want to use the definition opposite, adjacent, hypotenuse. So we know this is 0 degree, this is 90, this is 180, 270, and back to 360, which is equivalent to 0. Now we're given theta is between 90 and 180, so that's in this quadrant. So every time you have this type of problem, you want to remember the bow tie that I drew for you guys. So remember this bow tie. That's how you create the right triangle on a specific quadrant. So we're going to create this right triangle because we're on the second quadrant. Okay, so that's what we're going to do. So here's the right triangle we're after. And theta is right here coming out from the origin. So across from theta, so here's my 90 degree. Across from theta is opposite, which makes this adjacent, and this is hypotenuse. So what do we have? We have sine of theta that's given to us. So sine is opposite over hypotenuse. So our opposite is going to be 2, hypotenuse is 9. So we're looking for the adjacent side. Once we find the adjacent side, we're ready to answer the question. We're going to read off what is cosine theta. So using Pythagorean's theorem, what is cosine theta? Well, let's hold on to that, but let's figure out the missing length. So we have a squared plus b squared is equal to c squared. And we're missing one of the leg, so it could be either A or B. Let's label 2 as A, question mark is B, and C is 9 squared. So what is question mark square then? Do you guys have the number?
I think it's square root of 77.
Okay, right. So 9 squared is 81. 2 squared is 4, 81 minus 4, 77, and take the square root. Yep, Correct. So question mark is equal to a square root of 77. Okay, so now we're ready to answer the question. What is cosine of theta? Cosine theta, well, cosine is adjacent over hypotenuse. Now keep in mind that your adjacent side is sitting on the negative x direction. So question mark is actually negative 77, okay? So keep that in mind when you have an angle right on the xy plane, because once you're beyond the first quadrant, some of the sides are gonna have negative sign. So you have to keep that in mind. So cosine is adjacent, which is negative square root of 77 over hypotenuse, that's 9. So there we have our cosine value. Now you can also check that cosine is negative based on the acronym we gave last time, all student take classes. So S means only sine and cosecant positive. Only those two trig functions are positive, which means everything else will be negative. So it makes sense to have cosine a negative value. Any questions on this?
Yes, I do. Sorry.
Go ahead.
So whenever they restrict the angles or they tell you which quadrant, so they're always referring to a coordinate plane, right? A triangle and a coordinate plane.
Right. So every time you have this type of question where they give you a boundary for theta, that means you have to draw it on a specific quadrant.
So then things like cosine, and you have to pay attention whether cosine or sine is negative. But let's say the last example we did where it wasn't a coordinate plane, but it was more of like a triangle. We don't really have to be careful of whether cosine or sine is negative or positive, right?
For something like this, right?
Yeah, so we don't have to think about whether cosine is negative or positive, right?
Right, because here you're doing composition of inverse trig. So you're not really putting the right triangle on a quadrant. You're just drawing the right triangle.
Okay, thank you.
So Richie, coming back to you one more time. So you ask, why couldn't we just assume that 2 is equal to cosine and then 3 is equal to sine? So
Yeah.
one answer I give you was that because those are the definition of a right triangle, the length, right? Now, think about it this way. If you were to rewrite cotangent as cosine over sine, what is the definition of cosine from the right triangle?
Adjacent over hypotenuse.
Right, adjacent over hypotenuse. And then sine is opposite over hypotenuse. So then what you really have is hypotenuse will cancel out. You have adjacent over hypotenuse. So that's why these values, 2 over 3 that we had, 2 corresponds to adjacent and 3 corresponds to hypotenuse. Because you're purely using the definition to rewrite cotangent, and cotangent is not just simply cosine over sine, it's adjacent over hypotenuse. Does that make sense a little bit more?
Yeah, but yeah, it does. Yeah.
Okay. All right. Just thinking about it. Okay, cool. All right, so going back to where we were, right, little backtrack. So, all right, so that was number 8. So any other question you guys want to see from spring 2018? So let's go back to that final one more time. So here's the final. Let me know if you guys want me to show work for any other questions from here.
They have the number 16. They have a okay. So for the perform the division and simplify, you just keep change and flip, right? And you multiply.
Right, you factor. So do you want to see how that's done?
Yeah, please.
All right, so let's do that question. number 16. So that's also something we did a while ago, right? It's been a while since we did any factoring. Okay. So for this question, we want to perform the division and simplify. So like Richie said, you'll do the keep, change, and flip. So, and then you can factor out everything. And then we'll cross out like factors from top and bottom. So we keep the first fraction, which is x squared plus 2x minus 3 over x squared plus 8x plus 16 times, and we flip the second fraction, so that would be 3x plus 12 over x minus 1. And now from here, you can just factor everything completely. So helping out, what are the factors for the first fraction on top? So we want to find two numbers, right? That
X
gives
plus
us
3 and x minus 1. No, wait. Yeah, x plus 3, x minus 1.
right. It looks like that's gonna work. So if you want to check if your factors are correct, you just redistribute. Now what about the bottom? Can that be factored?
Yes, x plus 4 and x plus 4.
Mm-hmm. Right, so it looks like this works. Okay, now for the second fraction, for the top, we can pull out a GCF, which is 3. Then we have x plus 4 left. And then on the bottom, it's already a nice factor, x minus 1. If you want, you can put parentheses around it just to make it look nicer, but you don't have to. Okay, now is the fun part. You start canceling out terms. So x plus 3, no common factor on the bottom, so it doesn't cancel. X minus 1, yes, cancels with this one. And then x plus 4 will cancel with one of the factor from the bottom. So what are we left with? We have a 3 times x plus 3 all over x plus 4. And that is our simplified answer. Now, if you want, you can distribute and then write out the answer in that form. So if I distribute the top, I have 3x plus 9 over x plus 4. So any of these are fine. Okay, any questions on this? All right, any other questions? Okay, so let's go back to spring 2018 and see if we can do a couple more from there. So let me know which question you guys would like to see from this final.
Number 7.
Number 7, okay. All right, so let's do number 7. So for number 7, we want to find the domain of this function. All right, so here's the question. And we want to find what is the domain of this function. So what do you guys think? How do we approach this question? Any suggestions? So we have a denominator, right? And we also have a radical on the denominator. So we have to consider a lot of things, right? Well, two things really. So we have to consider one, that it's well, the denominator is not 0. That's one. And we also have to consider that it's greater than 0. Right? So the denominator is greater than 0. So to put the two conditions together, we can just say, okay, take the denominator and set it greater than 0. And that will fix the problem for 1 and 2. So we take what's inside the, in the denominator, that's 9 minus 4x, set it greater than 0. So the reason I'm not setting it equal to 0 because it's in the denominator and it cannot be just equal to 0. And now we get rid of the square by squaring both sides. So we have 9 minus 4x, which is greater than 0. And then we start solving for x. So subtract 9 from both sides. So we have minus 4x is greater than negative 9. And then divide both sides by negative 4. And when you divide, you have to make sure to do what? Do you guys remember?
Flip the sign.
Right, because it's inequality, we have to flip the inequality sign. So now it becomes less than 9 over 4. So that's our domain in inequality notation, but we want to write it in interval notation. So we want everything less than 9/4, so that would be negative infinity up to 9/4. So that would be our domain. Any questions? Does it make sense?
Yes.
All right.
Can we do number 6 next?
Number 6, okay. All right, so let's pull up number 6. Okay, so for number 6, we want to find the, let's see. Okay, so it's the net change and average rate of change. Right, so we haven't done that in a while. So that's a good question to review. Okay, so here's number 6. So let's find the net change and the average rate of change for the given function at the given t values. So like I said, the first point is always your A, and the second point is always your B. Now, who can tell us what is the formula for net change?
Is it f of b minus f of a divided by b minus a?
That's average rate of change. So you gave me the whole thing. Net
Oh.
change is just the top
Right.
of the average rate of change. Okay, so net change is just f of b minus f of a, just that. And then the average rate of change, it's the net change over b minus a. So this would be f of b minus f of a over b minus a. So that's the average rate of change. Okay, so now that we know the formulas, let's plug them in. So we know our a is 2, so we want to find f of a. Well, a is 2, so that's f of 2. Plug in 2 into the function, so you have 2 squared minus 2 times 2. So that would be 4 minus 4, which is 0. So f of a is 0. Now f of b is going to be f of 2 plus h. So that whole expression represents f of b. Now plug in 2 plus h into t. So we have 2 plus h squared minus 2 times 2 plus h. So now this one you have to expand because it's going to give us a lot of terms. Okay, so 2 plus h squared, that's 4 plus 4h plus h squared. And then here I distribute the -2. It's -4 minus 2h. And then by combining like terms, I have, so the 4 and -4, they cancel out. And 4h minus 2h, that's 2h plus h squared. And that I cannot simplify, so that will be my f of b expression. So now we're ready to plug these into our formula. So net change is going to be the difference between the function values, f of b minus f of a. Our f of b is f of 2 plus h, and our f of a is f of 2. So we have f of 2 plus h, that happens to be 2h plus h squared, and f of 2 is 0. So that's that. Now again, when you write the answer, it's just 2h plus h squared, because minus 0 is really nothing. So that's our net change. Now what about the average rate of change? Well, you take the net change and you divide by b minus a. So for the average rate of change, we take the net change, which is 2h plus h squared, and you divide it by b minus a. So our b was 2 plus h, a was 2. And if I do further simplification, I have 2h plus h squared on top, and here the 2's will cancel out, so we have h on the bottom. And finally, I can factor out the top, pull out a h, so I have 2 plus h all over h. And now I can successfully cancel out the h's, so that will give me 2 plus h. And there you have your average rate of change. Any questions?
So if we get a question like that, we will have to put both answers, right?
Right, so it'll give you a space for average rate of change and a space for net change. So these two questions are always connected.
Okay.
Right, so I think there was a homework question on this too. So if you did the homework, then you know what I'm talking about. All right, yeah, so any other questions?
Number 9.
Number 9, all right. Here comes number 9. Cool, so number 9 is, okay, so graphing exponential functions. Nice. Let's do some graphing. Okay, so here's number 9. So we want to graph this exponential function and label, label its domain, range, and asymptote. Okay, so well, we know how exponential function look like, the basic graph, right? We said if the base is greater than 1, if the base is a whole number, then we have the following graph. So if this is the basic graph for any exponential where the base is greater than 1 and it's a whole number. So we're looking at a base 2 for this function. So if I were to rewrite f of x, so we have f of x is negative 2 to the x plus 1. And then we can identify each transformation. So the negative in front of the 2, what kind of transformation is that?
It's a reflection over the x-axis.
So this is a reflection about x-axis. Nice. And then what about this plus 1?
It's just one up.
Right. So this is just going to go up 1 unit. Okay, so those are the transformation that we're going to apply to this basic function. So we start off with this graph. This is 2 to the x, and it goes through the point 0, 1. And it has a horizontal asymptote at y equals 0. So all of that belongs to the initial graph. Now we're going to reflect about the x-axis to obtain -2 to the x. So if I reflect, I will have something that looks like this. Right, use your best imagination. It should be symmetrical. I know I didn't make it symmetrical. This is 0, -1 now. But the asymptote hasn't changed. It's still y equals 0. So this is -2 to the x. Now from here, I'm going to shift up 1 unit. So that means my asymptote is also going to move up 1 unit. So now we're going to label the new asymptote first and then do the graph. So now our asymptote is going to be sitting at 1. So that's right here. Since we move up 1 unit. And the point 0, -1 is also going to move up 1 unit. So now that'll be sitting right here. And then you just preserve the shape. Something like this. So that's our new function, or the final sketch. F of x is equal to -2 to the x plus 1. So now from the graph, you can label the domain, range, and asymptote. So the domain of f is going to be what? What's the domain?
-infinity and infinity.
Right, it's always all real numbers. Now what about the range?
Is it -infinity and 1?
So it's -infinity and 1 open, because 1 is the horizontal asymptote. And then we have a horizontal asymptote at y equals 1. Now keep in mind, some of you, I noticed that you just write the number 1, or if that was the scenario. You have to write it as an equation, y equals to 1, okay? Because asymptotes are equations. So just keep that in mind when you type in your answers. Any questions on this? Oh, label at least 3 points on the graph. So we only label 1 point. We need to label 2 more. So we have this point 0, 0. How can I label more points on the graph? Okay, if you want to label more points, you just pick some x values and just plug it in, right? So since the domain is all real numbers, I'm free to pick any x value I want. So I'm going to pick nice ones. I'm going to pick x equal 1. So if x is equal to 1, plug in 1 into the equation. You will have 1 minus 2 to the 1, which is 1. So 1 minus 2 is -1. So that's right here. If x is 1, y is -1. So yeah, my graph is not up to scale. So I'm just gonna say this point right here is 1, -1. And then I wanna label one more point. Let's do -1, right? If x is -1, what do we have? So if x is -1, f of -1 is going to be 1 minus 2 to the -1, which is 1 minus 1/2, and that would be 1/2. So when x is -1, let's suppose this is -1, we have the point 1/2. So this point is -1. Yeah, sorry for all of that. Let me just erase this piece because I don't need that anymore. Okay, so now I can label the point. So here we have -1, 1/2. So there you have 3 points labeled on the graph. So always pick the point of transformation that's on the graph. And then for the remaining ones, just pick any random x values within the domain, plug it into your function, find its y value. All right, so that completes this question. Any other question you guys would like to go over? Okay, do you guys have any other particular questions that you'd like to see? So remember, this is your time. You want to get some review done so that you're ready for that final next week.
Something that I couldn't really get into where those circles with the circumference and the radius, and I also couldn't do the homework for that one. So I don't know if there's some questions about them.
Allison, are you looking for something like the arc length and the area of a sector?
Yeah.
Yeah, okay. So we do have, so let's see if this final does have a question, and that was on our quiz. So let me pull out something else. Let's do fall 2018. So we'll have a different question to work with. So here you go. So this is fall 2018. Let me see if I can find something. Okay, so this is nice. So number 4, find the radius of a circle if an arc of length 15 meter on the circle subtends a central angle of 5 pi over 6. Okay, so let me copy that here and then we can work on this. Now for the arc length and for the area of a sector, you want to remember those two formulas we derived in class. And the formula, I show you guys a little trick. How can you remember them, right? Without kind of forgetting them. You can always recall those formulas by knowing the area of entire circle and a circumference of entire circle. So in this case, we're, oh, hold on. Okay, can you guys see my OneNote?
Yeah, we can.
Yeah, okay, thanks. All right, so this is from fall, I forgot which, okay, what the heck. Short-term memory. Just a second. Fall 2018, okay. All right, short-term memory loss, fall 2018. So let's review the formulas a little bit and then we'll come back to this question. So for arc length, or a length of a circular arc, so you have the entire circle, which has a length of, which we call it the circumference, right? We don't call it length. It's going to be 2 pi r. That's the circumference of the entire circle, right? So you have some distance r, and then you have the entire circle of 2 pi, and circumference is 2 pi times r. Now, if you're just looking at a portion of the circle, so say you're just looking at this slice, and you want to know how much this length is. So we don't want to know the length of the entire circle. We just want to know that part, and that is determined by theta. So we take the circumference and multiply with theta over 2 pi. So 2 pi's cancels out. So you have r times theta is equal to the length of this circular arc. So that's how we get the formula S is equal to r theta. Now what about the area? Well, the area of a circle, the entire circle, is equal to what? What's the formula? Pi r squared, right? Now, again, you're just looking at a portion of it. So we're just focusing on this sector right here. So again, that is determined by theta. So you'd multiply with theta over 2 pi, because we're only looking at a portion. And then the 2 pi's the pi's cancel out. So our area of a sector comes out to be 1/2 r squared theta. So these are the two formulas you want to remember when it comes to these particular questions. Okay, now we're ready to apply. Which one are we going to use? Well, we're looking for r based on the arc length. So you're given S. Arc length is S, which subtends central angle of 5 pi over 6. So we're given theta. So you're given S, you're given theta, you can find R, so we're using this formula right here. So let's plug everything in. Now, another thing to mention is that these two formulas have theta in radians. So that's also something to be mindful of, because if the theta is in degrees, you must convert before plugging it in. So our theta is already in radians, so we don't have to do anything. We just plug them in immediately. So we have S is equal to R times theta. I'm looking for R, so divide both sides by theta. So we have S over theta is equal to R. And now we can plug in our values. S is equal to 15 and theta is equal to 5 pi over 6. That is the R value. And then of course you simplify this. So if I simplify this, I have R is equal to, so I have 15 times 6 over 5 pi. And then the 5 and 15 can simplify. That's 3 left over. So R is equal to 18 pi. That's how big the radius is. Okay, any questions? Does it make sense?
It's a little confusing, but I think I got it.
Can
Okay,
we do another one?
another one like this?
Yeah.
Okay, so so let me see if I can pull out another question from probably another final. So the key idea is to remember these two formulas, and then based on what you're given, you can determine which formula to use. So I'm looking at fall 2015 now. So let's look at that one. So this is fall 2015. Okay, so this final doesn't have any questions on that topic. Okay, no big deal. Let's pull out from somewhere else. Okay, so now, so let's do this problem. So find the length S of the arc that subtends a central angle of 90 degree and a circle of radius 18 meter. So what do you guys think? Which formula are we going to use based on what you're given?
S?
Right, we're going to use S is equal to R theta because it says find S based on this is given and this is given. So pretty much it's telling you which formula to use, either the arc length or the area of a sector. So S is equal to R theta, and we have to make sure theta is in radians. Now in this case, theta is not in radians, it's in degree. So we must convert this theta. So how do you convert 90 degree into radians? Or do you have it memorized? What is 90 degree in radians?
Pi over 2.
Pi over 2. Multiply with pi over 180, and you should have pi over 2. So that's a very special angle that we remember. Now what is R? R is 18 meter. Okay, so we're ready to plug everything in. So we have S is equal to R times theta. So R is 18 and theta is pi over 2. And then if you multiply these 18 pi over 2, you get 9 pi. So that is S. Any questions? Okay, does this make sense a little bit more?
Yes.
All right, so let's do another one. Unless you guys have a question from another topic. If not, then I will just do another question on this topic. Okay, so here's a good question to work on. Now this one is a little bit more work, but we can still do it, right? No big deal. Here you go. So here's another question. And this one is also looking for the arc length. Okay, so the answer is right there, but let's assume we don't see the answer. What the heck? Right, I get to see the answer, so that's kind of cool. Okay, whatever that is, it's gone. All right, so we want to find the length, the red shaded arc, assuming r is equal to 7 and theta is equal to 100. So r is 7 and theta is 100. But we're not looking for this arc, right? This arc corresponds to this theta. We're looking for this arc right here, which means we need to find what is this theta is in order for us to use the formula for the according arc. So how do we find the theta that we need for our formula?
360 minus 100.
Right, because the entire circle is 360. If we take away theta, we get the theta that we want. So we know S is equal to R theta, but we're looking for our theta, which is given by 360 minus 100. And that would be about 260. That's the theta we want. We want this theta, because this theta corresponds to this arc. So now we have theta, but we must convert, right? We cannot do this without converting. So what is this in radians? So we do pi over 180 and simplify the numbers. So we have 26 pi over 18. Yeah, let's keep it as 26 pi over 18. You can simplify further, but for now I'll leave it here. And what is r? Well, r we already know, which is given in the question. 7. So now plug everything into the formula. S is equal to R times theta. So we have 7 times theta, which is 26 pi over 18. And then the rest is multiplying these numbers. Can I simplify them?
You could simplify 26 over 18. It will be like 13 over 9 pi.
Okay, so 13 over 9. Great. And then the rest we cannot simplify, so we just multiply them. What's 13 times 7? Oh, 91. And then we have a 9 on the bottom. So that will be our arc length. Any questions? Okay, so yeah, that's pretty much it. And there's just one more question on WebAssign, but I think you can figure that one out. Okay, any other questions, guys? All right, so are you guys ready for the final?
No.
Not yet? Okay, we still have a little bit less than a week, but still have about like 5 days to go. So hopefully you'll have some more practice to work on. I strongly encourage you to work on fall 2018, spring 2018, and fall 2015 final, since those are actually pretty good questions and pretty relevant to the final you're gonna see. And then of course, finishing up your WebAssign homework, that's important since that will help you to understand how to input answers.
So unless for the, let's say that we miss homework from a long time ago and we just want to get it done for extra points. We can't.
How many homework are you talking about?
There's like 2 weekends that I missed.
2 weekends. I'm not sure if I'm going to open up that many assignments right now.